Alright then, year 6. So we are learning to calculate the area of a shape. Same what as yesterday because it's quite similar to the lesson we did yesterday, so you need to have that understanding of what we did yesterday, of area, before we look at today. It is a little bit tricky today, just an extra step involved in it. But if you could do the work yesterday, then you'd be able to do the work today as well. So just to recap about this word here, the area of a shape. It is essentially the number of squares within a shape. Okay, so if we were to look at this question here, this rectangle here, 11 centimetres across, 6 centimetres up. Remember, it's the number of squares within the shape. Now, it take me a long time to draw the 11 lines down here and the 6 lines across to work out how many squares there are in the shape. It's a far easier way of doing it by multiplying the width by the height. 11 times by 6, we all know, is 66. The unit of measurement is in centimetres. This time I remember to put the squared symbol because it's the number of squares within the shape. Okay, so could you have a go at this one for me if this one was 9 metres and this one was 5 metres? You might have to pause the video there, or you might just want to write it down quickly. What area is this shape? Just a quick recap what we did yesterday. So multiplying the width by the height, 9 times 5 is 45. The unit of measurement this time is m for metres, and the squared sign there because it's the number of squares within the shape, 45 metres squared. Okay, so that's what we looked at yesterday, and we are looking at something today, still looking at area, but it is a touch more complex. Okay, there's an extra step involved in this. So we've got a shape here, and it's a 1, 2, 3, 4, 5, 6-sided shape. 6-sided shape is a hexagon. It's not a regular hexagon because the sides are different length, so it's an irregular hexagon. And again, we're looking for the area of this shape. Now, we looked at shapes similar to this last week. We looked at perimeter. So if we were to find, we've got 2 missing sides here, haven't we? This side here as well as this one here. They are 2 missing lengths, and we need to find out what those lengths are first of all to begin to do this. So if we look at this one first of all up here, and if we look at this one down here just like we did last time, that's 10 metres. If I was to extend this out here like this, if that's 10 metres and this is 6 metres across here, this dotted line is also 6 metres. So from here to here, we know that's 10 metres. This dotted line is 6. 10 take away 6 is 4. So this line here has to be 4 metres. Right, now if we're looking at this one now down here, if this is 8, so that means this section here from here to here is also 8. This section is 3. 8 take away 3, so this dotted line has to be 5 metres. Now we can begin to find the area of the shape. Now, when we had this shape, it was very straightforward to do that because it was 9 times 5, because it's a rectangle. It's still a shape that is quite easy to find the area of, whereas this shape, because it's not a rectangle, it's quite tricky. So there are 2 different approaches that we can do for this. Okay, so I'll show you both the approaches. The first one is to imagine that it was a complete rectangle, and this dotted line can be quite useful. So imagine this was a complete rectangle. Here you could do 10 times by 8, which is 80 metres squared. That's if this was a complete rectangle, but we know it's not because there's this section here that is not part of the rectangle. So you could work out what this area is here that is actually not part of the original shape, and you could do 5 times by 6, which is 30, and then you could subtract it, couldn't you, because this is not part of the shape, to get to 50 meters squared. So can you see, by working out, making it into a rectangle and then taking away this extra bit that is not part of the shape and then subtracting it, you get to 50 meters squared. So that's one way that you can work out your answer, okay, by making it into a rectangle and taking away the section that is not there. So that's one way. So I'll just put that over there for now. So I'll rub this off and go back to our original shape. Another way you can do this is by splitting this shape up into two rectangles. That's another way that you can do this. So if I was to split this shape up, and I'll split it across this way. If I've split my shape up there, I'll just rub this line off that I did earlier. I've split my shape up there into two rectangles. Rectangle 1, rectangle 2. So if we were to work out the area of rectangle 1, first of all, completely ignoring this one here now, just looking at rectangle 1, 4 and 5 are the lengths of the sides here, 4 and 5. 4 times by 5, so the area of rectangle 1 is 20 meters squared. Now we've worked out rectangle 1, so let's ignore that and look at rectangle 2 here. Let's work that one out. And this rectangle is 10 times by 3. 10 times by 3 is 30 meters squared. And if we were to add these two up, we don't need to do that in column addition because it's nice and easy. 30 add 20 is 50 meters squared. And you can see the two answers, the two different methods, are identical. So it doesn't matter which way you prefer. I've taught people before who really like this method of boxing it out and making it into a rectangle. But I've also taught lots of people who don't like that method and prefer splitting the shape up as well. The shape also did not have to be split that way. It could have been split down this way into another rectangle, and you could have done 6 times by 3 to get to 18, and then you could have done 8 times by 4 to get to 32, and add them both up, it would have got to 50 again. Okay, so you've seen 3 different ways we could have actually solved that problem and got to 50 meters squared. So if we have a look at this one now, so the first thing we need to do is to calculate what these missing lengths are. Okay, that's the first thing we're going to do. So you might as well just stop the video there. See, don't calculate the area just yet. Stop the video just there. See if you can work out what this missing length is here and what this one is going across. Alright, so if this is 3 centimetres and this is 3 centimetres, these two will total this long one down here, won't they? Because both of these would add up to this long one. 3 and 3 is 6. So we've worked out one. Now we're looking for the length of, excuse me, we're looking for this length along here, aren't we? So it'd actually be quite useful to do a dotted line across. Now from here to here, that's 8 centimetres. And then this bit is 3. So if we have 8 subtract 3, this dotted line here will be 5 centimetres. That dotted line is identical to this edge here, so that will be 5 centimetres. And you can see there that we've worked out the length of all the sides. Right, now let's work out the area now, okay? So if I put a dotted line up there, that might help. Right, so we've looked at different methods we could do, 2 methods. First one is to work out the whole of the rectangle and then subtract this little extra bit. And the other method we looked at is splitting the shape up. So whichever method you preferred from when we did this one a moment ago, whichever method you preferred, could you have a go at please calculating the area of this shape for me? So you might want to pause the video there whilst you have a go at it, and then I will tell you how it should have been solved. Okay, so let's have a look at the first method where we've boxed it out into a rectangle. Find out the first rectangle, take away this extra one here. So 8 times by 6, because that is the full width and the full height of this rectangle. So we've got 8 times by 6. Then when we've got that, we can subtract this answer away from here. So 8 times by 6 gets us to 48 centimetres, doesn't it? Then if we work out this area here, 5 times by 3, because this is 5, this is 3, 5 times by 3 is 15. And then we can subtract them, because this bit here that we've just worked out, this area, is not actually part of the shape, is it? And it will give us the area of this. So let's work this out. This will be 3, this will be 3. So our area of this total shape is 33 centimetres squared. Number of squares within this shape are 33 centimetres squared. So I'll leave that there and we'll double check with our answer when we do it the other way. So if I rub that out now, and we can split our shape up. Remember, it doesn't matter which method you prefer. Sometimes it's quite useful to be able to do both methods actually. So if we were to split the shape up, let's split it this way first. We'll do it all the ways. So we've got rectangle 1, rectangle 2. So let's ignore rectangle 2 for now. Look at rectangle 1. It's actually a square, not a rectangle, this one. So we've got 3 multiplied by 3. 3 times 3 is 9. So this square at the top is 9 centimetres squared. Let's look at this one down here now. And it is 8 times by 3. That's the height. 8 times by 3, 24 centimetres squared. If we add these two up, 24 add 9, it also gets us to 33 centimetres squared. Now, some people might have split the shape this way, which is absolutely fine. And if you've split it this way, let's look at rectangle 1, rectangle 2. So this one is 3 times by 5. Remember, it's not 3 times by 8, because 8 is the whole length and it's been split here. So it's 3 times by 5, which is 15. So the area of this one is 15 centimetres squared. And if we're looking at this one, it is 6 times by 3, which is 18 centimetres. Remember, it's not 6 times by 8, because that would be the whole. It's this section here, which you know is 3. And then if we add these up, 18 and 15, it again equals 33 centimetres squared. So hopefully, no matter which method you did, the first one of making it out into a big whole rectangle and taking away the extra, this one where it was split across that way, or this one which we've just done split down there, hopefully no matter which method you used, you got to that right answer. So we will look at one more now, and this is the last one we'll look at. It's a slightly more complex shape, but exactly what we've done previously works for this one. So you can see it's a slightly different shape, isn't it? 1, 2, 3, 4, 5, 6, 7, 8. It's an 8-sided shape. It's actually an octagon. It's an 8-sided shape. It's clearly not a regular octagon. It's an irregular octagon. 8 sides to this. And you can actually see all the lengths I've put in for you already. 3 metres, 10 metres, 10 metres, 10 metres, 3, 5, 4, and 5 metres. So again, there are different ways you could do this. You could split the shape up. This time you might have to split the shape up a couple of times, or you could create one big shape by putting a dotted line across there. So could you pause the video there? Could you have a go at calculating the area to this shape? Okay. Alright then, so it might have helped you to actually draw this shape out, just because it's quite a visual problem this, so actually drawing the shape out probably would have helped you. So first of all, let's look at method 1, which is to create just one big rectangle. So if we've done that, and we're going to just for a minute ignore, pretend this little section here is not there and it's just one big rectangle. And if we were to do that, the width is 10, the height is 10, so it's 10 times 10, which is 100. So this whole rectangle, the area is 100 metres squared. But the shape is not 100 metres squared, is because we've got this section here that we need to take out. This across is 4, going up is 5. 5 times 4 is 20, so 100 subtract 20 gets us to 80 metres squared. Okay, so I think that method there is by far the most efficient method. By efficient, I mean the quickest method that you could have done to solve this. So 100 metres, 80 metres squared. 100 metres, take away 20 is 80. So that method works for that one. And again, I'll put that there and we'll check. So another way you could have done this. Now this shape obviously can't be split just once. It have to be split twice to work it out. And knowing this method is also really useful for some other shapes that are difficult to put into this rectangle. So we could split it across this way, or it could be split down here and down here, and we will do it both ways. So if I do this now, and now I've got 1, 2, 3 shapes. 1, 2, 3 shapes. So we need to work out the area of all of those and then add them up. So if we look at shape 1, it is 3 by 5. So the area of this one is 15 metres. And then this one is identical. It's 3 by 5 again. So that one is 15 metres. If we look at this one down here, this is where the extra work comes. Now, if this whole one is 10 and this one here is 5, this one will be 5 as well. So we need to do 10 times by 5, which is 50 metres. And then all we need to do, I'll just rub out, I numbered my shapes. We add these up. 50 add 15 add 15 gets us to 80 again. So we can see that method is a little bit longer, not quite as efficient, but being able to do both can be really beneficial to solving a problem. So let's have a look at the final way we could have done this. We could have split this shape like this as well. And again, we've created 1, 2, 3 rectangles to work out this shape. So we can see, let's have a look at the last way. So let's work out this one. It is 10 times by 3, which is 30 metres squared. Worked out 1, let's work out 2. If this whole one here is 10, this section is 5, so this section here has to be 5 metres again. 4 times by 5 gets us to 20 metres squared. And this section here is identical to this one. 3 times by 10, 30 metres squared. And then all we need to do is add up those 3 numbers. 30 or 30 is 60, add 20 is 80 metres squared. So you can see there, year 6, quite a lot of maths going on there. And there are 3 different ways of getting to that answer. The most efficient way in this one was creating that complete rectangle and taking away this additional space. But knowing how to split up a shape can be really useful for some really quite tricky shapes that you might have to calculate in the future. Okay then, year 6. So there is a worksheet attached to this on Google Classroom for you to have a go at. If you don't print it out, it's probably useful for you to draw these shapes yourself. Remembering, don't use a ruler, don't draw them as in, don't use a ruler with a measurement. Use a ruler to actually draw the shapes, but don't do the measurement because they're not drawn to scale. But it might be useful for you to draw them out, so you can do the dotted lines, because it's quite a visual task, this one, and being able to actually visualise it to split it up does help rather than you having a look at it on a screen. Okay, so I would recommend you try to draw out these shapes, and once you've done that, you can send them back to your teacher either as an attachment or a photo, and then we will do some more work on this tomorrow.